Hello, my name is Adil Azman, and today we'll be looking at 6.3 heat transfer and thermal equilibrium. Today we're going to explore the fundamental concepts of heat transfer and thermal equilibrium and how they relate to molecular behavior. So what is heat transfer and thermal equilibrium? Heat transfer is simply the movement of thermal energy from a region of higher temperature to a region of lower temperature. Thermal equilibrium, on the other hand, is the state where there's no further change in temperature between two substances or objects in contact. So, a key point to remember is that when two substances reach thermal equilibrium, their average kinetic energies become equal. This means that the particles in both substances are moving with the same average kinetic energy. It's important to remember that the kinetic energy of the object is equal to 1/2 mv squared, m being the mass of the object and v being the velocity of the object. So, collision theory plays a crucial role in heat transfer and thermal equilibrium. For heat transfer to occur, particles must collide, and these collisions require sufficient kinetic energy and proper orientation. Sufficient kinetic energy is needed to overcome the average energy barrier and allow for energy transfer. Sorry, I meant activation energy barrier. And these molecules or particles must have correct orientation so energy transfer can happen. It's important to remember that when harder particles collide with cooler particles, heat is transferred between them, and once thermal equilibrium is reached, there is no more net transfer of heat. Okay, let's look at a practice problem. We have 75 grams of iron at 95 degrees Celsius, and we place that into 150 grams of water at 20 degrees Celsius. What will happen to the temperature, average kinetic energy, and average speed of the iron? So the first thing to note is that the iron's temperature is greater than the temperature of the water. This is crucial thing to point out when looking at these problems. Because iron's temperature is greater than the water, iron's temperature will have to decrease to reach thermal equilibrium. Therefore, the temperature of the iron decreases. When temperature decreases, average kinetic energy also decreases. Basically, iron's average kinetic energy will decrease, and it will eventually become equivalent to water's average kinetic energy. Important thing to note is that water's average kinetic energy will also increase. Because average kinetic energy decreases, average speed will also decrease. Thank you.